The first lab was about the amount of excess charge on an ordinary object. The goal of the lab was to learn about electric force and how it can be transferred between surfaces. Additionally, the lab aimed to teach us to measure the amount of excess charge on a piece of tape. In the end, I got a total excess charge on the tape of 1.82 times 10 to the negative 8 coulombs. Some of the physics principles that we explored were Coulomb's law, which explains the relationship between electrical force between two charged objects and the quantity of charge on the objects. Additionally, we needed to understand Newton's second law to see how force equals mass times acceleration. Additionally, a big part of the lab dealt with electric force and the electric force equation, as well as how positive and negative charges interact with each other. The lab began by you pulling on one piece of tape off of another piece of tape and having the tape interact with objects to see how the charges react to one another. Then two pieces of tape were brought towards one another until the tape obviously repelled each other. This was in order to measure the amount of excess charge on the tape. Two assumptions were made during the lab. Each U-tape has the same net charge because they were produced the same way. And it was also assumed that the charges were located at a single point at the center of the tape. I calculated the excess charge on the piece of tape using the formula electric force equals K times Q1 times Q2 over D squared. Because the tape was not moving, the net force must equal 0. This means that the electric force must be equal to -1 times the force of gravity. Using the formula gravity equals mass times acceleration due to gravity, you get the force of gravity equal to -0.00196 newtons. By plugging in 0.00196 newtons to the electric force equation, you get that the charge on each piece of tape is 1.82 times 10 to the negative 8 coulombs. Here you can see the code in the GlowScript model. In the GlowScript model, the orange arrow represents the force of gravity, and the red arrow represents the electric force. As you can see, the arrows are the same size, which is consistent with the fact that on the piece of tape, we said that there was a net force equal to 0, meaning that the electric force must be equal to -1 times the force of gravity. Overall, based on the interactions that I saw regarding the U-tape, I came to the conclusion that my U-tape had a positive charge to it, as it repelled other positively charged objects and it attracted negatively charged objects. Through my calculations using the electric force equation, I calculated that the U-tape has a total excess charge of 1.82 times 10 to the negative 8 coulombs. If electrons had positive charges and protons had negative charges, protons and electrons would still be attracted to one another. However, electrons would now repel positive objects and protons would now repel negative objects. Another thing to note is that it was very important to not touch the U-tape very much during the experiment. This is due to the fact that your hands contain water that will cause the charge of the tape to transfer to your hand, making the tape more neutral. This would lessen the effects that we are supposed to observe during the experiment. One difficulty that I ran into was that my tape was not showing a very strong repel to the other tape. This is likely due to the fact that the room that I was in was very humid, and so the charges were transferring to the water molecules in the air. It would also make the tapes less likely to repel one another if one of them is neutral.